So today we're going to be going over how to convert from decimal to binary and how to build such program in the C programming language. Now, to give a very brief overview of what binary is, as throughout this video we're going to be dealing with binary a lot, and you guys will eventually catch on to it. Binary is a base 2 numeral system in which the numbers that we know and love are depicted in either ones or zeros. Now, this is very important in the realm of computing because at the lowest level of computing is basically operated by hardware that has either on or off switches at its most fundamental level. And on is depicted as ones and off is depicted as zeros. So that is how binary relates to computing. I know what I just said is a very grave oversimplification of what binary is, but don't worry because binary is in every single aspect of computer science. So, how do we convert from decimal to binary? Well, the method that we're going to be using in this video is called successive division. So I think it is best explained by a demonstration. So say we have the number 375, right? With successive division, we're going to take this value of n and we're going to divide this by 2. And when we divide this by 2, we're going to get a remainder. Now, because we're dividing any number by 2, we're always going to have a remainder of either 0 or 1. Sounds familiar because that's what, binary deals with. Not to mention that binary is a base 2 numeral system, so this all checks out very neat. In this third column right here, we have n modulus 2. This is the modulus operator. In coding and in programming, the modulus operator is used to pull the remainder from a division that has occurred. So say we are going to divide 375 divided by 2. So let's go ahead and do 375 divided by 2. So 375 divided by 2. It's going to give us 187.5. Now, we have a remainder of 1 in this, since 187.5, another way of saying that is 187 remainder 1, right? So since we have a remainder of 1, we can just put 1 right here. So if you were ever programming and you invoked and called upon the modulus operator, it would be pulling back and giving you the result of the remainder that happened in this division, which from 375 divided by 2, we got a remainder of 1. So that is basically the modulus operator in its simplest explanation. So we're just going to keep on going from here, which is what successive division calls us to do. So we're going to do 187 divided by 2, which is 93.5. And another way of saying 93.5 is 93 with the remainder of 1. Then we're going to put 93 in for n again. So 93 divided by 2 is going to give us 46.5, which is 46 with the remainder of 1. Then we're going to put 46 divided by 2, which is 23 with the remainder of 0, as there is no, 0.5 or decimal. Then we're going to put 23 divided by 2, which is 11.5, which is also 11 remainder of 1. And then 11 divided by 2 is going to be 5.5, which is also 5 remainder of 1. Then 5 divided by 2 is 2.5, which is also 2 to the remainder of 1. 2 remainder of 1. And then we're going to do 2 divided by 2, which is 1 with the remainder of 0. And then 1 divided by 2 is 0.5, so 0 with the remainder of 1. And we are done with it since we have reached at our second column 0. Now, we have a ton of 1s and 0s on our third column, so how do we read this? We're going to read this from bottom to top, aka we're going to read from our most significant bit, as this is a bit, and we're going to read that all the way to our what is called the least significant bit. So the conversion and answer to 375 converted to binary is the following: 1011101 11. And that is our answer from decimal to binary. So let's go over how we can create and implement a program in C that can take a decimal number and convert it into a binary value. I've already made like a skeleton of this function that we're going to create, which is the decimal to binary function. This function takes a parameter of n, which is an integer, and n is going to be the number that we want to convert into binary. So the first thing that we're going to want to do is to initialize an integer array that stores the binary number. aka what this is basically asking us to do is to create an integer array that basically, if we look at our chart here, store the remainder of the successive divisions that we do. So think of the third column of n modulus 2 as the very integer array that we're going to be storing either ones or zeros in. And this will be, of course, from the least significant bit to the most significant bit. That order and arrangement of bits when we load in information into our array will be important for the last step of what we need to do in this program. But we're going to get there. So the first thing that we're going to do is initialize this integer array. So we do int binary sum. And we're going to allocate 32 elements into this. These 32 elements are going to represent 1 byte each. 1 byte is 8 bits. And we have 32 elements in this integer array, so that when we express a 32-bit integer, which is what most modern systems hold integer values in, especially C, we'll be able to, when we get our newly converted binary value, we'll be able to make the program express a full range of values in binary. So that's why we're allocating 32 elements into this integer array that will carry our binary converted value. Next thing that we're going to want to do is initialize a counter for our binary array for our iteration of division. Basically, what this is saying is that when we do our successive division, each successive division is an iteration in a loop. In this case, when we implement it, we're going to implement a while loop. And every time the while loop occurs, we have to implement a counter that will traverse elements in the integer array. So the reason we're doing that is because when we do our successive division and we get a remainder from that division, we want to store that remainder in the designated index that the successive division occurs in. It's best demonstrated when I code it out and then also demonstrate on the chart that we created when we did our conversions pen and paper. So let's go ahead and just initialize this counter. So int I will be 0, and then we can just start our successive division while loop. So this is going to be while n is greater than 0, which basically means that every time each successive division occurs, our n value is going to change. Just like in this graph, where after each division, when we did n divided by 2, n would turn into 187, and so on and so forth. Once that value can no longer be divided and we reach a value of 0 is when that loop is going to stop. That is where the successive division stops. But also in this loop, like I said earlier, we want to take the remainder of the division that occurs and store it in our binary sum integer array. And to do that, we have to traverse through each index of the array through the loop, which will require us to, what we did up here, initialize a counter and then increment the counter as the while loop goes on. So basically what we're going to do here is we're going to do binary sum I. So in the first iteration, it would go through index 0. It will update index 0 with the remainder. And that is going to equal n modulus 2. After that, we're going to update the value of n, which will be n equals n divided by 2. And then we're going to increment our counter variable with I++. So the next thing that we're going to want to do is that since when we create our binary sum array and we update values in it based on the remainders that we pull out of the successive divisions, the array is updated from the least significant bit to the most significant bit, which means we're going to have to reverse the entire array in order for us to get an accurate binary value, right? So that instead of reading it from least significant bit to most significant bit, we can read it from most significant bit to least significant bit as basically reading it from bottom to top. So to do that, we're going to initialize a for loop that will basically print out the integer array values but in reversed. So we're going to initialize a new int variable called j, which will be used for our reversal of the integer array. So for int j, which we will assign to I-1, which covers the entire length in indexes of the integer array itself. We'll do j is greater than or equal to 0, and we will decrement the j variable with j minus minus so that we know that we are traversing backwards in the integer array. So from the index all the way to the right of the integer array, which will be whatever highest index will be, and this for loop is going to decrement the j variable down and down and down and down and down, and it will stop when j is greater than or equal to 0. We're going to call upon printf, and we're going to catch the integer basically, and we are going to print each of the values that are in binary sum, but print them out at the index of j. And so basically, since we assigned j being at the very last index of the integer array, and we are printing from the last index of the integer array all the way until j will be assigned to the value of 0 on its last iteration, which means that the least significant bit is at index 0. Last thing we're going to do is call upon the function for testing. So we're going to create a int variable called decimal, and then we're going to ask the user to enter a non-negative integer. And then what we're going to do next is we're going to let scanf basically catch this integer that is input by the user. And then we're just going to call upon the method, which is dec to binary, and we're going to put that in for decimal. Now let's compile this to be dec to binary.c. Alright, so now let's do /gtp. It's going to ask us to enter a non-negative number, and we're going to enter 375. And we have our binary value that we got from when we calculate it in pen and paper. And you can rewind back and check for yourself. But that's going to wrap up for this video. I hope you guys learned something about converting from decimal numbers to binary values, and I will create videos on more number systems topic and computer science topics soon, so stay tuned for that, and thank you guys for watching this video.